Imagine a door, not between rooms, but between universes. A tunnel that could take you from one side of the galaxy to another in the blink of an eye. It's called a wormhole concept that sounds straight out of science fiction. But what if I told you that science actually allows such tunnels to exist, at least on paper? Today, we'll journey deep into the fabric of space-time to answer one big question. Are wormholes real or just theory? The idea of a wormhole begins with one man Albert Einstein. In 1915, Einstein introduced his theory of general relativity, showing that gravity isn't just a force, it's the curving of space and time. Now, imagine space-time as a giant, flexible fabric. If a massive object like a star sits on it, the fabric bends. And if it bends enough to distant points could theoretically touch. That's the wormhole, a bridge connecting to points in space or even to points in time. Physicists later gave it a formal name, the Einstein-Rosen bridge, a shortcut through the universe. It's like folding a piece of paper to bring two opposite ends together, then poking a hole through them. Instead of traveling all the way across the paper, you just go through the hole. That's the beautiful simplicity behind the wormhole concept. It's a direct consequence of the laws of physics as we understand them, born from the same mind that gave us EMC. But a mathematical possibility is one thing. A physical reality is something else entirely. Could something so strange actually form in our universe? But can these bridges really exist? Einstein's equations don't forbid wormholes, but nature. That's another story. To keep a wormhole open, you'd need something truly bizarre, negative energy or exotic matter. Think of regular matter like a planet or a star. It has positive mass and energy, which pulls things in with gravity. Exotic matter would do the opposite. It would have negative mass, which means it would repel gravity. It's the kind of stuff that would push space-time outward, propping the wormhole's throat open and preventing it from collapsing on itself. Scientists have never found such stuff in nature, yet it's purely theoretical, a placeholder in our equations. And even if we did find it, there's another huge problem. Stability. According to our current understanding, a natural wormhole, if it did somehow form, would collapse instantly faster than a beam of light could even pass through it. Enter one side and get crushed in the singularity before you ever had a chance to see what S on the other side. So, for now, while the math says wormholes can exist, physics suggests they'd be incredibly fleeting and impossible to travel through. Of course, movies love wormholes. Interstellar, Doctor Strange, Star Trek, they all show humans traveling through them like cosmic highways. In the movie Interstellar, the wormhole that appears near Saturn lets a team of astronauts reach a completely different galaxy in search of a new home for humanity. And, believe it or not, the science behind that movie was based on real physics. The film's science advisor, renowned physicist Kip Thorne, actually co-authored papers on the subject. He proved that traversable wormholes are mathematically possible as long as you have that exotic matter to hold them open. The visual representation of the wormhole in the film, a sphere of distorted light, is considered one of the most scientifically accurate depictions ever put on screen. So, while fiction is definitely taking some liberties, it's not entirely detached from reality. Science fiction is often just science waiting to happen. The ideas explored in these stories push real scientists to ask, what if, and explore the very limits of what's possible. And modern physicists haven't given up on that question. In fact, the search for answers is more active than ever. In 2022, researchers at Caltech and Harvard announced they had simulated a tiny holographic wormhole inside a quantum computer. It wasn't a real tunnel through physical space, but it was a system of quantum bits that behaved, mathematically, just like a wormhole. This was a baby step, but a profoundly important one. It was the first time we could experimentally test theories about wormholes in a lab environment. Some scientists believe that understanding wormholes could be the key to unlocking some of the universe's biggest mysteries, like time travel, quantum teleportation, and even the existence of parallel universes. If we ever learn to create and stabilize them, wormholes could change everything about human existence, our methods of travel, communication, even our fundamental understanding of reality itself. Imagine sending a message instantly to a colony in another galaxy, or meeting your future self through a tunnel of curved space-time. It sounds crazy, but then again, so did the idea of flying through the air or talking to someone on the other side of the world once. So, are wormholes real? For now, they remain beautiful mathematic solutions to Einstein's equations that are not yet proven, not yet seen. They are a tantalizing possibility, a cosmic what-if hanging in the vastness of space. But we should remember that every great discovery began as just a theory on a piece of paper. Black holes were once just a mathematical curiosity to a strange prediction of general relativity that many physicists, including Einstein himself, doubted could be real. And then we captured an image of the shadow of a supermassive black hole at the center of the M87 galaxy. Maybe somewhere out there in the infinite universe. A wormhole is quietly waiting, a cosmic doorway, a bridge between worlds, just beyond our reach. For now, until we find it. Keep looking up, because the next great discovery might already be watching us back. Thanks for joining us on this journey. If you enjoyed this exploration of the cosmos, don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure.